Hello.
Hello.
Hi.
Hi,
Hi,
how are
Steph.
you?
Hi, Stephanie. How you doing?
I am doing great. How are you? What's your name?
I'm Nelson.
Okay, hi
I'm Nelson.
Nelson. Nice to meet you.
Nice to meet you. This is my first time doing this, but I heard that you can help me with my homework.
Yes, I can. So with these virtual sessions, if you had a problem with your homework, you just describe to me the problem and I'll help you do it on the board. And you
Okay,
should be able
perfect.
to see what I'm writing. So it's pretty interactive. Let me know if at any time you can't see something that I write, and I'll be sure to move it over so it's
Okay.
within your line of vision.
Well, I'm logged into the iMathAS,
Okay.
and I'm in section 2.1, and it's problem number 11 that I'm stuck on.
Okay, can you see what I just finished writing? 2.1, number 11.
I see the number 11. Yeah.
But you don't see 2.1.
No.
Okay, I'll be sure to fix that. Sometimes I can't write on all of this board, but we're still figuring out where I can write.
That's
Is that better?
yes. I see that.
All right, perfect. So can you describe to me the problem?
Sure. It says, determine if each ordered pair is a solution to the given system.
Okay,
If so, type Y in the answer box. If not, type N.
all right, perfect. So if you can give me the equations.
Sure, there's two of them. The top one
Mhm.
says x plus y equals -6.
Okay.
And the second one is 3x minus y equals -2.
Mm-hmm. And now
And
your
they have
ordered pairs, right?
two ordered pairs. Yeah, there's two of them. The first one on the left says
Says, I believe you cut off again. I'm checking this time, I'm not muted. But it sounded like you said says and then you slowly died off. So I'm not sure. I believe it was -2, -4 was one of them. Was it -2, -4? And then your other ordered pair. Oh, I heard something. Oh no. We're having mic issues, I think. It's not me. Can you hear me? I would start working on the problem. I can do the problem actually with this ordered pair. So if we work on one ordered pair at a time to see if this is a solution to the system, what we're going to do is first label that this is -2, it's an x, and this is my y. Oh, I think I heard you. Hello? Oh, I guess not.
is 0 comma -6.
0 comma -6. Can you hear me?
Yes.
Okay.
Sorry, I'm having a little problem with my microphone here at home.
Oh, okay, it's no worries. I wasn't sure if it was my side or your side, but were you able to hear me the entire time?
Yes, yes.
Okay, all right, no worries. So what I might do is sometimes I would try to continue the problem at least a little bit until you get back to me, in case anyone else is watching. I'll try not to go too fast and I'll pause and wait until you can regain
Okay,
connectivity, and I wouldn't
that
mind
sounds
going
good.
over it with you.
Thank you so
So,
much.
yeah, no problem. Thank you for sticking around. So, for what we're going to do is we're going to first check to see if this ordered pair is a solution to the system. And by doing that, we're going to plug them into both equations to see if it's true. So, we're going to first test it with -2, -4. And we
Okay.
just plug it in. So, I labeled it. So, here we're going to plug it in. -2 plus -4 equals -6. Okay? And so
Okay.
this plus minus can actually be -2 minus 4. Adding a negative is the same thing as subtraction, equals -6. When we simplify, -2 minus 4 is -6. So that's -6 equals -6.
Yes, that's true.
Yep, it is true. So it's true, but remember, we still have to test this ordered pair with the second equation. Just because it's true in the first doesn't mean that it's a solution to the system. It has to be true for both equations.
Do I do that with the second ordered pair or the
Yep.
same first one?
You do it with the second one. Oh no, we will do the second ordered pair, but we're doing just the first ordered pair
Okay, that makes
because
sense.
they want an answer for both. They want, is this a solution and is this a solution, right?
Oh, gotcha. That's a lot of work.
Yeah, it's a it's a little bit of work, but it won't be too bad. I'm right here and we'll do it together. Well, I actually started doing it with the other equation, but we're gonna do it with oh, yes. Actually no. You see what we're doing here? We're doing with this
Mm-hmm.
equation and
Mm-hmm.
just plugging in the same points. So 3 times x, remember our x is -2,
Two.
minus the y, so that's -4,
Minus 4.
equals
-4.
-2.
Oh, I would have
Minus
forgotten the
-4.
parentheses.
Yeah, that actually happened to me a little earlier with a similar problem. So 3 times -2 would be then -6.
-6
Minus negative becomes a positive, so that's
plus 4.
+4. Yep. It's sometimes a little extra work just writing this, the minus, and then when you're substituting to do parentheses, but it really helps you not forget in case some people might overlook it and they think, oh, I'm plugging it in here, but you overlook a negative and you would have
Mm-hmm.
written -6 minus 4. So be careful on
Awesome.
that.
Okay.
It's a little extra work, but it'll be worth it for you to get the right answer. -6 plus 4 now is -2.
2 equals
Mm-hmm.
-2.
Yep. And so now this is true. You see how now they're true for both equations?
Mm-hmm.
So that means that this ordered pair is a yes. It is a solution to the system of equations. And a system of equations simply means that there's more than one equation. So you see how we have 2 equations to work with?
Mm-hmm.
That's what system of equations means. More than one equation.
Okay.
Okay?
So now what do I do with the second ordered pair?
Now with the second ordered pair, we do the same thing we did with the first. Plug it into both of these equations and see if they are both true. They both have to be true for it to be a yes. Make sense?
Yes, that makes sense.
So we'll try it with the first equation and the second
So
ordered pair. So,
0
0. And
uh, plus
yep.
-6 equals -6.
Mm-hmm. Can you still see this, by the way?
Yes.
Okay. And now this becomes -6 equals
-6 equals
-6.
-6. So that's true.
That is true. And now when we're testing it with the second equation, still with the second ordered pair, so 3 times 0 minus -6
Minus -6
equals -2. And anything multiplied by 0 is just 0.
is always 0.
Negative minus is a plus.
Positive.
Mm-hmm.
+6 equals -2.
Yep. Is that
Oh
true?
no, it doesn't. It doesn't equal.
Yeah, no, this is not true. So you see how we have one equation, when we plug
Mhm.
it in, it's true, and the other one, it doesn't?
Yeah.
Overall, it's a no. It has to be true for both. If even one of
Both.
them is wrong, it's
Uh,
just type in no right away.
no.
Just no. Yep. So this is a solution, but the second ordered pair is not. First ordered pair is a solution to the system. The second is not. All
So
it
how do
is
I
just
put
plug it
it
in.
in the system?
Come again?
It says enter your answer as letters.
Oh, as letters. So,
Example.
right. So they just want to, if it's a yes, then just type in Y. And
Okay.
just no. Is that what they said, I think?
Yeah, oh, I see. There's 2 blanks. Okay, it was confusing at first, but I can see the first
Okay.
blank is the first ordered pair. The second blank box is the second ordered pair. All right, thank you.
You're welcome.
Hey, Stephanie, I
Yes.
have another question.
Okay, yeah, sure, Nelson, go ahead.
So this question is from a section, and all the other questions are the same.
Okay.
It's section 2.3,
Okay.
Problem number 1, actually.
All right, no worries. And can you describe to me the problem and the section title if you
Yeah,
can?
sure. It's the title is Solve Systems of Linear Equations by Elimination or Addition.
Okay.
All right, so it says solve the system of equations by the addition elimination method. Note, type in the 00 for infinity many solutions
Mm-hmm.
and DNE for no solution.
Okay.
It gives me two equations,
Okay.
and it says enter your answers in the form of x, y, where
Okay.
x equals blank and y equals blank.
Mm-hmm.
I can give you the two equations.
Yes, please.
The first one is 2x
Mm-hmm.
plus 3y equals -1. And then the other the other equation, I'm sorry, is -2x minus 2y equals -2.
Okay. Can you see how I wrote 2.3 number 1 over here?
Absolutely.
Okay, perfect. So when it comes to the elimination and addition method, you might see it one way or the other. It both means the same thing. We're trying to eliminate the variables, and we're going to eliminate one variable at a time. So the whole point of this is to check, do we want to eliminate x's or y's? And what
How
we
do I
want to
know which
check,
one to eliminate?
right, we're going to look and compare. So we see this is a 2x and this is a -2x. We're going to end up adding all of these down, your x's, your y's, and then the constants over here. You see how they have the coefficients, so the numbers in front of the variables, 2 and -2? You want to have the same value but opposite signs. So this is a +2, this is a -2. Positive 2x, -2x. That means that when you add them, what's going to happen? They're going to cross out, right?
So I cross the x's out?
Yes, because they're already set up that way. You have a positive 2x and a -2x. So when we're adding these down, we have 0 x's left down here. And in
Do I
this
have to write
case,
the x also and
you
just
don't
say
have
0x
to.
equals 0?
You can, but I wrote it down just so you can see what would happen. You can just write down 0 if it's a lot easier. So
Okay.
just a regular 0. And we're going to end up adding all of these down. So x's cancel out. What about the y's? Remember when we're adding, we're only adding the numbers in the front, and we keep the variable the same. So 3y minus 2y is,
1y,
yes, and it's a positive 1y, so
positive 1y.
plus y. And you could choose to write the 1 in the front if you want to or not.
Yeah.
It's up to
Yeah,
you.
no.
And then same thing when we're adding the coefficients, -1 plus -2. Two negatives added together make a bigger negative number, so it's
A
-3.
bigger -3.
Yes. And when we simplify this, it'll be y equals -3. Does this make sense so far?
Yeah.
Keep in
Uh,
mind that whenever we're doing elimination or substitution, your equations should be set up so that it's in this form. ax plus by equals c. And you want one equation to be right on top of the other. You're always going to be given two equations, and you want to make sure it's in this form. Your x's and y's are on one side equaling a number, which is your constant. A, B, and C are numbers. Does that make sense?
that makes sense.
Okay. So when we solve for y, once you have one variable equaling a number, you can plug that in to either equation to get x, whichever one you want. Either equation, I'll even label it equation 1 or equation 2. Which one do you feel like plugging it into?
Let's do equation 1.
Okay, so if we plug y into equation 1, you'll still get the same answer regardless of which equation you pick. We'll have 2x plus 3, and because y is equal to -3, we're going to substitute that. So 3 times -3 equals -1. So are you with me so far?
Yeah.
Okay. When we simplify, it'll be 2x plus 3 times -3 is -9. So plus and negative is just minus if you want to
Just
erase that
minus.
plus. And then is equal to -1. So when we're solving for x, we want to add 9 to both sides. 2x is equal to -1 plus 9 would be positive 8. And then we're going to divide by 2 to both sides. So x would be equal to 4. And if you want me to write down what we did here, this is we added 9 here, and divided by 2 to both sides. This is a positive 8, by the way. I'll just erase that. So does this make sense?
Yes. So x equals 4.
Mm-hmm.
-4.
-4? Or is it
Positive 4,
4?
I'm sorry. X
Yes.
equals +4, and then y equals -3. So I
Yes.
entered that into iMath.AS, right?
Mm-hmm.
Okay. Okay. I was confused at first because I thought it was like x equals 0 because we determined up there is not 0, but it's not really that. You have to plug it in to get x.
Yes, yes. You
Got
need to
it.
plug it in
Okay.
once, and you could have done it where you solved for the y's first. It doesn't matter whether you solve for y first or for x first. Just make sure that whichever variable you choose to solve for, plug it in to get the answer for the other variable,
Gotcha.
a
Yeah,
value
because
for
it
the other
looked like the
variable.
other problems were very similar. Some of them had the
Mhm.
x and the y on separate on different parts of the equation. So I
Mhm.
guess I just need to make sure I line them all up.
Yes,
So
make sure
x
it's
is on top
in
of each
this
other, y is on
form.
top of each other.
Right. Make sure it's in this form before you try to do elimination or addition
Perfect.
method, whatever you choose to call it, and you should be fine after that. And remember that the whole goal is to make sure that before you cross it out, they have to share the same value but opposite signs. You see how this was a +2 and this was a -2? That allowed for our x's to cancel out. We could have also done it with the y's. In this case, our y's are not matching. But if we wanted them to, what number would we want them to be? This is a +3 and a -2. We would have to multiply something to both equations.
Like a fraction?
Not necessarily. A number that they can both go into, like 6. If I wanted this to be a 6, I would have to end up multiplying this by 2 and this by 3. There will be some, in this case, we just had it where our x's were able to cancel out, but there will be other questions in this section where you might have to manipulate the equation a little bit more. But if you have any questions, you can always come back and ask me. I know this one didn't demand it, but if you did have a question with one of those, be sure to come back and let me know, and I'll walk you through it.
Hey Stephanie, are you still there?
Yeah, I'm still here, Nelson. What's up?
Hey, I'm now in section 2.4, and it says solving a system of linear equations by substitution now.
All right, perfect. So
Um,
substitution.
yeah, and all the questions look very similar to one another, so I just really need help with number 1.
Perfect. So go ahead and read me. They should have given you 2 equations.
Yep, it looks similar from before.
Yeah.
The first equation is x plus y equals -30.
Okay.
And then the second one is, it's weird because it just says y equals 4x.
Okay. Awesome. So for substitution, what you want to keep in mind is the word substitution. Substitution means plugging in something you already know. So you want to find y equals or x equals for one of your equations. I'll label this equation 1 and equation 2. Do we have either x equals or y equals for equation 1 or equation 2?
This
Like
is
just y equals.
just the y equals, yeah.
Right. So you see how
That's 4x.
equation 2 is like that? Y equals
Mhm,
4x. That's
mhm.
exactly what we're looking for.
So it didn't
So
really matter if it was x equals
it
or
could
y
have been
equals.
x equals, right? Either or. But you want to find it with a coefficient of just 1.
Okay.
So you see how this just has a 1 in the front?
Oh, okay.
That
Yes.
that's very, very key. That will make substitution a lot easier for you. So if we rearrange it, if we had to rearrange it where you isolate x or y and get it to one side of the equation. Because equation 2 is already set up for us like that, all we have to do is plug it in. So what we're going to end up plugging in is, if they give us this as an identity, almost, you want to think about it, y
Mm-hmm.
equals 4x, they're telling us that y is equivalent to 4x, and we can substitute that in for the y in the first equation. So if I were to rewrite this, I'm going to rewrite the first equation, x plus, instead of y, I'm going to type in 4x equals negative 30,
30.
right? So you see how instead of writing y, I substituted for 4x because my second
Mm-hmm.
equation told me that y is equal to 4x. So I can make that substitution. Now,
So,
mhm,
okay, that makes sense. Okay.
yeah, so and the whole reason we're doing this is because I can't solve a system with two variables. I know only how to solve it with one variable, or at least that's what we know so far. So when they give us this, we're able to substitute it. And you see how now we only have an equation with only one variable, only x's?
Mm-hmm.
I can combine those now. X plus 4x is
Be
5x,
5x,
right? Equals negative 30. And
negative 30.
if I were to solve for x, I would divide by 5 to both sides.
Divide both sides. Mm-hmm. And you're left with x equals
Mhm.
-6. Yeah.
Yes, negative 6. And remember, what you want to have is a value for x and a value for y. Once
Yeah,
you
because it's
have,
coordinates. It looks
yeah,
like it's a coordinate that I need to enter it in.
it is a coordinate. It should be, your answer for these will be ordered pairs, because what we're doing mathematically is we're finding the intersection where these two equations, if we were to graph them, they will cross at one point in the graph.
And that's
So,
the solution.
and that's the
That's what,
solution.
oh, okay, that's what the
Exactly.
professor is saying, that the intersections are solutions, and
Yes,
that's what we're doing right now. Okay.
exactly. So this x is the x value of the ordered pair. So you're halfway done with the answer because we have the x value, but we still need the y value. So when we're looking for our y value, you can take this x and plug it into equation 1 or equation 2, whichever one you want. Which do you feel like doing?
Let's do equation 2 because it seems easier.
Yeah, it is easier actually. Good job, because you see how it already says y equals. So if you plug that in, it'll already give you your y without moving anything too much. So y equals 4 times negative 6. Are you able to still see what I'm writing?
Yep.
Okay, perfect. So you see how I plugged in this x for negative 6?
Mm-hmm.
Now all I do is simplify. 4 times negative 6 is negative
Negative
24.
24.
And we're done with that one. This
Oh
will
wow,
be,
so y is a big number, negative 24. Okay.
it can be, yeah, you can have big numbers or small numbers. But now our final answer then would be, actually, let me do this in here. An ordered pair, negative 6, negative 24. Right? Because this is our x value and this is our y value. So this is the ordered pair that they're looking for. If you're able to see that. Are you able to see that down here? Possibly. Did I accidentally mute myself? No, I didn't. I'm assuming you can see it. But yes, just make sure to write your answer as an ordered pair, and that should be substitution for you in a nutshell.
All right. That makes sense.
All right, cool. Did you have any further questions about this problem or any
No,
others?
I kind of wanted to work ahead a little bit and go to the next section.
Okay, yeah,
2,
sure.
2.5. I also want to do the first problem in that section.
Okay, perfect. So I'll go ahead and erase this. And then 2.5, I believe, is graphing.
Yeah, there's
Okay.
graphs already here. It says graphing linear inequalities and systems of linear inequalities.
Oh, okay. Awesome. I like that you're working ahead, by the way.
Yeah, I just want to make sure I get this done tonight.
Yeah, perfect.
Let me see. So it says, um, graph the line of, and then it gives me an inequality, and then answer whether it is shaded above or below.
Okay.
And there's a hint here. It says make sure to extend the line all the way from one side of the graph to the other. I guess that's for shading.
Yes. So that's 2.5. And can you go ahead and repeat the question one more time for me?
So it says graph the line of, and it says negative 3x minus 2y um, is less than or equal to negative 4.
Did it look like this, less than or equal to?
Yeah, yeah.
Okay, then that is less than or equal to. All
Okay. All right,
right.
sorry.
No, it's all good. You did it perfectly fine. So what we're going to do here is we want to first make sure we have our equations set to y. This equals can be the inequality. It can be less than or greater than or equal to, less than or equal to, less than or greater than,
Mm-hmm.
and then mx plus b. So basically everything else. Your m, remember, is your slope, and your b is your y-intercept. Right.
Mm-hmm.
And then x is all that. But the main point is to isolate y. This y right here. So this y. You want to get it all alone. So if I were to do that, what would you want to move over first? The -4, the 3x,
Let's
the
take the
2y.
3x and put it on the other side.
Perfect. That's exactly what we're going to do. So -2y is less than or equal to -4 plus 3x. So we added 3x to both sides. I'll go ahead and write that here. Well, are you okay with following along how we went from here to here?
Yeah,
Okay,
yes, yes.
then
And I don't change the sign or anything like that, right?
no, we only changed the sign if you mean this sign, not this sign,
Yeah,
right? Yeah,
yeah.
the inequality. We change the inequality, we flip it when we either multiply or divide by a negative number.
Okay, that's in my notes. Okay, that makes
Yes.
sense. Okay.
We're almost there too, because you see how we are really close to isolating this y, but we're multiplying by a -2.
Mm-hmm.
So in order to isolate it, we need to divide by
Oh,
-2.
divide by -2.
Yes.
Okay.
So if we
Okay. So,
divide by -2, we do that to everything.
oh my gosh. Okay.
I know it looks a little bit scary, but -2 divided by -2, in order to keep this mathematically correct, we need to do it to every term in the equation. So -2y divided by -2, -4 divided by -2, and 3x divided by -2. And then after, we simplify. So the -2's cancel out. This will be left with just y. Because we divided by a negative number, we're going to flip the sign, so it's going to be greater than or equal to. -4 divided by -2 is just +2. And then 3 divided by -2, you can leave it as a fraction. So plus, you could do plus -3 over 2 or 3 over -2. When you have a negative either at the denominator or in your numerator, you can take it out. So this can be like a -3 over 2. Does that make sense?
Yeah. Yeah.
Okay,
So
I'm
the
just
whole
gonna write
thing
that.
is negative.
The whole thing would be negative, yep. And then x is just outside. If x is in the numerator, you can bring it out in the front like that. So are
Okay.
you okay with how we got here?
Yes.
Okay,
But
perfect.
the X is in the wrong spot. So do I need to
It
move it
can
over?
be, yeah, it depends on what you feel more comfortable. If you choose to see, if you want to, you can move it to the front. So you can have it y greater than or equal to -3 over 2x plus 2. As long as you keep the signs the same, if this is a +2 and this is a
Mm-hmm.
-3 over 2x, you can switch the order that they're in.
Okay.
You can leave it like this, or you can rearrange it to have it like this.
Yeah, I
Whatever.
like it like that better because it looks like
Yeah.
the linear, the y equals.
Yes. Yes, it does. Okay, yeah, perfect. That's perfectly fine. Once we have the equation, we can now graph it. So when we're graphing it, we just, are you able to see the graph that I just drew?
I did. I do.
Okay, this will be our x-axis, this will be our y-axis. And when I'm graphing it, I want to be able to see what my slope is. So this value right here, this is my slope, right? My m is my
Hmm.
slope, and my b value, which is my y-intercept. Remember, my b value is my
Yeah.
y-intercept.
I remember
So
when we're graphing that. Yeah.
yes. So when we're starting to graph it, when we look at our equation, I'm actually even going to box this because it's a very important equation. You cannot graph it without getting this equation. So
Gotcha.
I
Do I graph it the same way that I would graph like back when we were doing it normally with the y
yes,
equals mx plus b?
yes, you start with the y-intercept, so plus 2. So we go up 2 units. So if this is 2, this will be my first point. And then you apply your slope, -3/2.
And
Remember, that's
it's
why it's overrun.
that's right. And it's negative, so it's gonna go slanty.
Yes. So
Slanted to the
yeah, so it's going to
right.
go downwards, right?
Gotcha. So
So
it's going
then
down.
if it's
Okay.
negative, and you can assign this negative to either the 3 or the 2, and your other value would be positive. So if you wanted this to be a -3, then this is going to be a +2. You can also have it where this is a +3 and this is a -2. You'll still get the same slope. So I'll do -3. So if I start here, I'm going to go down 1, 2,
One,
3,
two, three,
and then I'm going to go over 2 to the right
two,
because it's going to be a
one,
+2. Right? It's going to be +2 because I decided to keep the 3 negative. If
two.
I
Okay.
also wanted to have the -2 here and this be positive, I mean, the same thing. If it was a +3, 1, 2,
One, two,
3,
three.
and then my -2 would be negative, so 1, 2.
To the left.
You see how it's still going to be the same line?
Same line. Yeah. Okay.
Make sense so
All
far?
right. Cool. Yeah.
Yeah, and this is an inequality, so you also had shading, right?
I have shading. The graph is shaded, and then it says below or above the line. How do I select which one is which?
That depends on the inequality. When you're looking at the inequalities, there's actually two things you want to be able to identify, and that's going to be what type of line it is and what type of shade it is. So when we're determining what type of line it is, it can be a solid or a dashed line. So can you see this below?
Yes.
Okay. So when determining the type of line, both less than or equal to and greater than or equal to is going to be solid. A solid line simply means that it's going to be solid just the way I drew it already. So you see how this is just all solid? Your other
Yeah.
option is that it could be a dashed line. That's with less than or greater than. So without the bar underneath, you almost want to think of this solid bar as like, oh, it should be a solid line.
Okay. That's an easy way to remember.
Yep. And then if it doesn't have the line underneath, then it's going to be a dashed line. Dashed
Dash.
lines just look like this,
So in this case, it's going to be a solid line because we
which is
have a less than or equal
right.
to, which is what you drew so far.
Well, we have a greater than or equal to. Remember, we flipped it in our calculation. This is less than or equal to. This is greater than or equal to. Right? Oh no, I think you cut off again. Come back. I'm almost afraid to keep writing down here. I don't know if you can see this, but now we're going to determine what type of shade it is. And when we determine the type of shade, that's going to be less than or equal to, or great, or just regular less than is going to be shade below. So shade below the line.
They do it below the line, or
Yeah, so less than or equal to and less than is shade below. And then greater than or equal to, welcome back by the way, is shade above. So are we going to be shading above or below the line?
I think you're doing above it.
Yes, above the line. If I were to do this on here, above the line would be, you see where I drew my line? It's going to
Yeah.
be all above the line is where I'm going to
Okay.
shade. So that's how it will look graphically.
Okay. Cool. Excellent. That makes so much sense.
Awesome.
It really does. Okay. Thank you so much. I appreciate it.
Yeah, no problem. Thank you again for coming to the session.
All right. Gotta go do homework. Talk to you
Okay.
later.
Bye.
All right. Bye bye.